Brad Neuberg. I'm with the Gears team. Just to start, I want to kind of gauge the audience and find out where y'all are. How many of you have experience with JavaScript and feel comfortable with JavaScript? Okay. And how many of you have worked with Gears? Okay. And how many of you have heard of Dojo or worked with Dojo? Good. So I'll be touching on all three of those topics today, and I'll be kind of giving a run-through of some of them, kind of some introductory material. And I want you to feel free, if you have a question, to please raise your hand, and then come to the microphone and ask a question if there's something during the presentation you have a question about or want more clarification on. So let's get started. So the agenda today is I want to introduce Gears very briefly, because it sounds like most folks know what that is. And then I want to talk about something called Pubtools Search, which is the focus of today's discussion. Then I want to give an introduction to the Gears modules that are used in this project. I'm going to talk about the search architecture for this client-side search system. I'll give a brief introduction to Dojo and the parts of Dojo that we use for this. And then I want to share some tips, some tricks, and some actual code. So all the code that you see today as I move through Dojo and so on is taken from the project. So it's a good introductory material for Gears and Dojo. So the first question, I think many of you already know what Gears is, but I want to quickly touch on what is Gears. So right now in the browser we've got JavaScript, CSS, HTML, but it's pretty constrained in terms of taking advantage of these really powerful machines that we have now. So you kind of see that there. We've got multi-core CPUs, we have 100 gigabyte hard drives. We're just not taking advantage of that. So what Gears does is it expands the capabilities of the browser to start really using the resources of the local machine. And it does that in a way that is cross-browser, cross-platform, even on mobile devices. And it ties in to what's known as HTML5. Gears and HTML5 work together really well. Gears is a way to help get parts of HTML5 out to existing web browsers like IE6, and it's a way to help sort of have innovation between the two. And one thing that's really important is Gears is open source. It's an open community. We've got public bug database, public code. It's really a place for people to work together. So that's sort of the high level, what is Gears. And one thing that's important is Gears doesn't introduce a new programming model. You can think of it as sort of, you've got a cake. At the center of the cake is the existing web technologies. And they're augmented with a series of capabilities like a real relational database, like the ability to run code without blocking the browser. And I'm not going to get to touch on all these capabilities today. I'm only going to touch on the ones that are used for this client-side search engine. So what is Pubtools Search? That's the focus of today. Well, the first thing that's really important is this is not a part of Gears. This is sort of an example project. It's an independent open source project that what it does is it gives you some simple scripts that you can drop into your web page, and you can sprinkle a little bit of HTML into that page to get a client-side search engine. So with that said, let's jump right into a demo to see what this looks like. Wow. Sorry about that. Firefox 3 opened up, and Gears is not out for that yet. So here we see a search form. This is a simple page. And in the background, you saw that processing manifest. What it was doing, it was downloading a list of URLs that actually points to a bunch of books from Project Gutenberg, books by authors like Goethe, Descartes, and it was actually indexing them into the local database, into the full-text search. So now, as I type in real time, it can provide results. So you see here, for example, as I type history, it brings back Descartes. And here's the ebook for Descartes. Right here is from Machiavelli. So in real time, this is Socrates' Apology as an HTML. So in real time, as we type, we can search over these resources. Right. So today I'm going to be going into how this was implemented using the tools that Gears gives you. Are there any questions about what this is? You good there? Just really quick, bring your question to the microphone for the YouTube video. Thanks.
So these files were local to the machine, and it indexed them into its own database. Is that correct?
Yeah, so it pulled them over the network, and you give a list of URLs. And I'll be showing how you use this from the outside and then the internals. But yeah, so you can give a corpus of documents that now the search happens locally on the client side. So a common question is why? Why would you want to do this on the client side? Well, the first thing is it's really fast. When you've got the ability to search locally on the client side, that means you can do real-time as the user types search, where network latency would kill you if you tried to do that over the network. The other thing is that you don't need a server. You can have a constrained corpus of documents. It could be a set of employee documents. It could be some technical documentation that you can really constrain things to. It's simple. As you'll see when we talk about how to use it, it's really simple to use. And one of the things that's really important is it's a good Gears example. This is a suitably complex example. It's more than a hello world. It's some example code that you can look over that uses worker pools, that uses the full text search in a way that you can really use as a template for your own projects. So let's talk about how you use this, and then I'll talk about the internals. So the first thing you do is you create a really simple text file that has a list of URLs to index. So right here you see a bunch of text files, some HTML files of different books. And then you give a version for this bundle. In your HTML page, you pull in a little bit of CSS, you pull in a little bit of JavaScript. So there we are grabbing the CSS to show these results and the JavaScript. Then you need to point to your list of files, and you use the link tag for this. So you say rel equals search.urls, and you just point to the file that has the documents that you'd like to index. And then finally, in your HTML, you just drop in a div tag that has a well-known ID, st-widget, stands for search tools-widget. And when the JavaScript loads, it's going to insert that search form into your page. And then in the future, if you want to add a new document or drop a document, here you see it's highlighted. We've added a book by Virginia Woolf, and you just bump up the version number right there. So that's it. From a user perspective, you've gotten the ability to use parts of Gears without having to delve into JavaScript in a pretty straightforward way. And so moving forward, what I'm going to do is start talking about the internals. So how is this thing built? And before I can do that, I need to briefly introduce the Gears modules that we use. Do you mind turning on the timer? Thanks. So I'm going to have to run through these to a certain extent because this is not necessarily an intro to Gears, but it'll give you a sense of these different modules. So the first one that we use is the local database. And what this is actually local SQL storage. It's actually an open source project called SQLite. And it's really fun to use. It's a full-featured relational database. You have triggers, virtual tables, really the ability to do some cool things. And this thing has been stress tested. It's inside of iTunes. It's inside the Mac OS X core data. It's also inside of Gears. So it can really have gigabytes of storage capacity. And I want to quickly show you what some of the code looks like. So whenever you use Gears, you start with a factory object, and you get a handle to your module you want to work with. So right here, we grab the database. Then you open your database. You give them a name. And then you can run pretty normal SQL. Right here, we're doing a create table. Here's how you insert some values. Pretty straightforward. Notice the question marks. That's similar to like the JDBC prepared statement or those kinds of things. So you put question marks where you want things to go, and then provide the arguments at the end, kind of like printf. And then to get your results, here we are executing, getting a number of rows, and then you just loop using your results set. So while we have a valid row, here we are printing out the results. We're getting the phrase column and the timestamp column. And we're iterating to the next one. And one thing I want to show here, if you're writing this code, a lot of times I see it's really important to do this when you work with the database. Notice how we have the try and then we have a finally. If an exception gets thrown while you're working with the database, it's important to have a finally so that you close the resources that you worked with. Remember, these are OS-level resources. So you should close your results set and you should close your database. That's a little tip and trick when you're working with these things. I see people not doing that in their code, and this makes it more robust. So you might have heard about the full text search. This is really straightforward. There's a module called FTS2 that's a part of SQLite. And to use, you create what's called a virtual table. You use the SQL syntax. And you say you're using FTS2. That's the kind of the indicator. And then you provide the columns that you want to have be part of this full text search database. And then right here you see us searching. And what you have there is use the match keyword. So we're saying, give me the dish from the recipe table I just made where it matches some string. Right there you see tomatoes. And this is actually more than simple. You can actually do some pretty fun queries. So you can scope by columns. So right down there you see for the dish column, if it's a stew, and if it's a tomatoes from any column. So you can do some fairly sophisticated stuff. So the last sort of piece I'm going to just review is worker pool, especially when you start using the local database. If you're inserting a lot of rows, you're doing full text search, databases are constrained by the file system generally. And if you've got that running right inside the browser, you're going to bring it to a halt. And when we get to the tips and tricks, I'll talk about how worker pools can really improve both the performance and the perceived performance. The performance because things aren't locking down, and the perceived performance because things just kind of continue to work for the user. So this is one of the really good tips and tricks. And what worker pools are, they're not threads, because threads get into sort of shared state issues. They're independent pieces of code that run outside the sort of DOM that you're looking at. So you can sort of say, hey, worker, run this code, and then the worker will message back a result. So let's quickly look at what that looks like to work with a worker. So in this example, let's say we're trying to run a prime number algorithm on one of the workers. This is a great example because prime number algorithms tend to be really computationally intensive. So what we do is, first off, we use the factory. You get your worker pool handle. And then the way that worker pools and your main browser thread communicate is with messages. So we set an onMessage handler. This is the guy that will get the result, right? The worker is going to message back the result. Then you see a function called nextPrime. So you could imagine filling that out with an algorithm that will take a prime number and then find the next prime number. Now we're doing a trick here. The way that workers work, the way that workers run, is when you create one, you have to pass it a string that's the code to execute. Now you can imagine if you are building up lots of source code in a string, that's going to become really unmaintainable. So there's a couple of tricks you can do to make things more maintainable. One is you can put your worker code into a separate file. There's a function where you can say, initialize this worker from this URL. I'm not doing that here because it's really simple. Here I'm doing a trick using JavaScript. JavaScript is a really, because it's a dynamic language, I can stringify a function. So you actually see me turning the next prime function into a string, and then I run it. What's that? No, so for these parts, this is kind of plain vanilla. This is not from the client-side search engine code. You'll see that when we start jumping into the architecture. So the question was, is this source code from... So the question was, when you run string next prime, does that return the source code? Yes. If I were to print that out to the console, I would see exactly what you see there, function next prime in. So I've stringified. So this is a trick you can use in your code. So that run me variable becomes the function, and then I run the function. Okay? And then finally, I create the worker and pass it that string to run. And you'll get to see some more real world. Workers are really behind the design of this, pretty much. So now that you've had a very quick run through of Gears, I want to talk about the architecture, the high-level architecture of Pubtools Search. So there's a series of classes. The first one, there's a primary class called Search Tools. This is the entry point. I've kind of put some of the public and private methods here. JavaScript doesn't have access control. You can simulate it, but it gets nasty. So there's generally kind of an idiom of putting an underscore at the beginning or end of a method or property name to indicate that something's private. So here you see Search Tools as the entry point. I say, hey, search for this query, handle this error. And you can kind of see some of the implementation details. We have a UI class that kind of encapsulates printing out these results, responding in real time. We have a class called Search Manifest that does a couple things. One is it goes and it downloads that file that has a list of URLs. It parses it. It gets the version. Don't forget, we don't want to do this every single time. We don't want to reindex things every time the page loads. So it actually persists the version into the local database and then reads that to see if things have changed. And we'll be talking about the control flow, so you'll see that more. We have a documents class that is given that list of URLs that was parsed. And this documents class does two things. The first thing it does is it filters. It actually takes the URLs and it does a head request on each one to get the MIME type. Now we need the MIME type, as you'll see later, when we do snippet generation. But we also do it as sort of protective programming. We make sure that there's only MIME types we can work with, which is HTML, text, and XML. So if someone's put a Microsoft Word file in there or an image, it'll filter those out. And then this class proceeds to download the list of URLs and get the actual content. So again, we'll be talking about the control flow more, but then there's an indexer class. And actually, as we get each of the documents downloaded, we push it off to an indexer class, which mostly runs on a worker. And the job of this guy is to plug this into the full text search database and generate a title. Again, that's why we need the MIME type, as we'll talk about. And then finally, we have a searcher class. And this guy also runs on our worker pool. The job of this guy is obviously to do the search. So let's go through the control flow, because from a high level, this really lays out what's going on here. So there's really two major things, right? There's indexing and there's searching. So let's run through indexing. So remember I talked about search tools. Whenever you see the round, that means it's a class. And whenever you see a square, that means it's something we're doing with that class. So we start with the search tools class. At the very beginning, we get the database name. Now, I'll talk about in the tips and tricks, it's important to do this well. And I'll be touching on it. But getting the database name, you don't want to hard code just an application name. I'll touch on that. Then you need to create your database tables. You need to create your schema. And then obviously we need to wait for the page to finish loading. Now you'll see a little title whenever something's an asynchronous operation. Whenever you're working with workers, for example, they're naturally asynchronous. You'll see the little async label, just in case you can't read that. Okay, so the page is finished loading. We're in the UI. We obviously need to initialize the UI. What that does is it gets that div, it gets that well-known ID, and it writes in the user interface, the search field, and so on. Then we get back to the search tools class, and we need to figure out what's that search manifest URL. Remember I said we have a link tag that points to, that's in the head of the document, that points to it. It gets that. By the way, if you're making reusable frameworks, doing things using the meta tag and the link tag is a really good pattern. So you can kind of make your own rel for a link tag or your own value for a meta. This is a really good way to specify sort of input to make things reusable. Boom, now that we've got the URL to the manifest, we can make our search manifest class. And this guy then goes asynchronously, fetches that URL, that manifest, and then parses it into a list of URLs. And then there's a decision. Remember, we look in the local database, we say, what was the version of the last manifest file we dealt with? And what's the version of the guy we've got now? If they're different, then we need to index. If they're not, we're done. We don't need to index because we indexed last time. Okay, so now we're indexing. So whenever you see the little database icon, that means we're writing down into the database. It means that's interfacing with the Gears database code, API. So we need to persist this new search manifest version. And then we need to make our documents class. And this guy, like I said, he's given a list of URLs, and he filters them by MIME type. Again, this is an asynchronous operation because he's throwing out a bunch of head requests. And then, for HTML, XML, and text documents, we download ones that pass the MIME type test. And again, that's async. So it's really important. You could imagine making an indexer that has 30 documents and downloads all of them before trying to index. And that would simplify your code, but it would really create a system that takes much longer. Because most of the time, when we're downloading a document, we've got lots of time in between. So the way this works is as each document rolls in, we instantiate an indexer and pass it the contents. So that indexing is being interleaved with downloading because the network is naturally much slower, which results in better overall perceived performance by the end user. So that's good. When you're planning out a system like this, you can batch certain operations, but you'll want to interleave other operations. So the indexer runs on a worker, which means it's asynchronous, and it needs to extract the title. And that obviously differs. If it's a text file, we can't really extract the title on the client side. But if it's an HTML file, we can look for a title element. And then, oh, by the way, you see the little tools? That indicates this is running on a worker. And then we insert our new full text search row. And I'm going to show actual code from some of these types of things. You'll get to see what this looks like. And that's it. When all the documents are downloaded and indexed, we're done. We have indexed. So searching is actually much easier, but it happens differently. So the UI, the user wants to search using a query string. Just every time we type a key, we just recall search, the search method, passing in the query. And the search tools kind of exposes our public API to a certain extent. Kind of encapsulates us from the other things that are actually doing the searching. We say, hey, start this search. Search tools sets up a little searcher object, which runs on a worker. And this guy does two things. He executes the query against the full text search index, where this is important to do on a worker, because if you have actually, even with a small corpus, you want to do this. And then for each of the matches, you want to generate a snippet. So what's a snippet? You know when you search on Google and you see a little bit of text? Well, we need to do that on the client side now, because that's a dynamic thing. The snippet generally needs to match the search term. And it also matters what the MIME type is. So that's why we capture that too. So we kind of say things like, if we're a text file, just search for the query term, grab a snippet, and put bold around it. If we're HTML or XML, using a JavaScript regular expression, strip out all the tags, and then look for the text. So again, snippet generation is something that isn't really computationally intensive, but if you did it just in JavaScript without worker pools, it's the kind of thing that before workers would be hard, but it's very fast with a worker. Finally, we get our list of results that come back from the worker, and we say UI, display these results, and we're done. So that's the control flow for both parts of this. And I'm going to jump in and give you a brief intro to Dojo, because we use Dojo in this. At a certain point, you find that you're starting to roll your own JavaScript library. And that's when when you're making a small script, you don't generally need to use a library. But when you get to something more sophisticated like this, you want to start using a library. So I use Dojo. Of course, just to embarrass the two guys I knew were here in the audience, there's the two guys who co-founded Dojo over there. And Dojo is 3 pieces. It's open source. So you've got three big parts that you can use. One is called the core. This is really small. This is really competitive. Gzipped on the wire. It's about 24K. Gives you a lot of really cool stuff. Digit is actually the your widgets that you can drop into a user interface. And then Dojo X are sort of Dojo extensions. They're things that not everyone needs, but when you need them, they're really useful. Things like cross-browser drawing primitives, things like that. Today, I'll just be touching on core because that's the only thing that I end up using for this project. One thing I want to just mention is that Dojo includes a really unique build system that you don't have to use if you don't want it. You can just grab Dojo core. But for folks that have used Dojo, I did something interesting in this. Because Pubtools Search, one of its goals is to be dropped into an arbitrary page, I wanted to make a special build for Pubtools Search. And that was for two reasons. One is I wanted to make something even smaller than Dojo core. And again, Dojo core is already really small, but I wanted something even smaller. So I snipped out some things that I knew I didn't need. And more importantly, I wanted to rename space things. So I dropped it into pubtools-util.js because the web page that someone's using this on may already have a Dojo element of a different version. So what I did was I renamed space. Generally, when you use Dojo, you use like dojo.hitch, dojo.bind. I renamed space using the build system and made it pu for pubutils. And so I say dojo.hitch, pu.hitch. So when you're looking at the source code, as we'll step through this, you'll see pu.hitch. In your mind, that's dojo.hitch. So again, really useful if you need to do more advanced stuff with the build system. So let's jump right in. So this is actual code from the client-side search stuff. And the first thing I want to introduce you to is Dojo's XML HTTP request. How do you do that? So here's actually the download function that we talked about. It takes a URL to download me. And the first thing you see, there we are making the indexer. Now we're not indexing yet, but we need to tell the indexer how many documents are there total, because this whole thing is an asynchronous thing, and we need to know when we're done. And then you see a utility function from Dojo called forEach. So you pu.forEach, and what this does is this takes an array. Download me is an array of URLs. This is taking an array of URLs, and for each one, it's running that function, passing in the individual entry. And an entry object is something we created earlier that has a URL and a MIME type. That's what we captured. So you see that here, grabbing the URL, grabbing the MIME type. And then there we are calling a Dojo function that does a get. So it's xhr get. And all you do is you pass in the URL, and you pass in a load function and an err function. So the load function gets the data, and there you see, right when we get the data from a specific URL, because remember, this is going to get called. We're shooting off XHR requests for each URL. We pass it right into the indexer that we made earlier. So there we are calling the indexer. Here's the URL, here's the MIME type, and here's the data. And then in the error, a lot of times when you're dealing with lots of asynchronous code that's hitting a network or workers, it can be really useful to centralize your error management. So the search tools class has a method called handle error. So that's something that's really useful for you. So whenever there's an error across these different classes, we just delegate into search tools. We have that handle the error. Any questions about Dojo's XHR or this code? Yeah. Actually, do you mind going to the microphone? Thanks.
So it looks like your index function, where you call it index.index, you're expecting it to bring back textual data. If I inadvertently gave you a Word file or had a bad MIME type on an image file, I'd get garbage at that point. Is that correct?
Yeah, so the question is, this function expects textual data. What if there's a binary file or Word? So the step before this was the filter function, which got the MIME types, which we needed anyway. And it just only keeps the ones for the MIME types it knows about.
Okay, good. All right, thanks.
Mm-hmm. It's a little defensive programming.
Isn't the indexing performed by a worker?
I'm sorry, say it again?
The index, the function which really indexes?
Yes, yes. So the question is the indexer run on a worker?
Mm-hmm.
Okay, and we're actually going to see that code. So one of the reasons for some of these classes, again, you don't want to over-classify things. Sometimes worker code can get a little difficult to work with, so it's encapsulated in this indexer class. Inside of that is the worker code that we'll see. So JavaScript is a prototype-based language, and prototypes are great. Dojo gives you a facility to kind of make things feel a little bit more like a class system. I find this is they're both fine to use just plain prototypes. I find my code's more readable using this kind of syntax. So you have a function called declare. So right here we're saying pu.declare, dojo.declare. You give the name of the class. This is the searcher class, actually. Then you give a superclass. That's null. We're not doing subclassing here. I find actually in JavaScript, I almost never subclass. It's not something that happens too often. Class systems are pretty easy. And then you provide an object literal that has your properties and your methods. So right here, I've emptied out some of these methods so they're not so big, but you actually see there's the search function, which takes a query and a callback, because it's asynchronous. And then you see two implementation functions, escape string and get snippet. And you'll actually see we actually stringify those functions to run them on the worker. It just makes it more maintainable to keep them as methods of this, because they're logically kind of methods of that. So really, really straightforward way to declare classes. All right, hitch. Okay, so here's Dojo hitch. Here we're declaring the documents object that filters and downloads documents. And you see the first thing you see is we have a constructor function. This is how you, when you're using Dojo's declare, you need to be able to provide a constructor rather than, so here we're doing that. And here's where you see things happen. In our constructor, we call the filter function, pass it a list of URLs, and then we pass in a callback. So we say, after we filter, run the download method. Now, here's something interesting. If you look at the download method, it says this.do something, right? So it's running in the context of the class. Well, in JavaScript, functions are first-class objects. And if you're not careful and you pass in a callback that's a function, it won't be attached to an instance. So this will actually reference the window object. So lots of folks, when you first start writing JavaScript, you generally save references on the window object to your instance. Then you get a little more sophisticated and you say var self equals this and use a closure. Those are fine, but if you want your code to be even cleaner, a hitch type thing is really nice. So what that does is pu.hitch, we give the instance, so we're saying this, then we give the function, and it's gluing those together and actually returning a function that is now captured inside of this instance. What that means is that when download runs and calls this, it's going to actually refer to what you think it does. So if you're doing a lot of asynchronous stuff, lots of GUI type operations, hitch is really useful, especially when asynchronous code can get complicated very fast, or can get unreadable very fast. So these kind of things can help make this code more maintainable. So the last two things is Dojo query and Dojo by ID. Let's look at query first. Again, this is real code. So Dojo query, similar to what jQuery gives you, I can pass in a CSS selector to get certain parts of the page and then work with them. So right here, I grab the input element from my search control. And I use a class name, because I actually use the same CSS as the Ajax search control from Google. So I wanted to make those so you could style them the same. So right here I'm saying, grab me any elements that match that, give me the first one, and then give me the value. So this is a really straightforward, but you can do some very advanced things with Dojo query. You could say, get me all of the classes that are of some button, for some button or something. And then we're actually searching based on the query value. I'm just scratching the surface there. You should search for Dojo query if you want. It's very fast, too. By the way, I just want to say that I think one of the biggest changes the last year and a half has been moving more towards sort of standard DOM type things, like get element by ID and looping, to using these kinds of things. Because the last year and a half, the work of jQuery and Dojo query have really sped up binding onto your page using CSS selectors, and it can really make your code much easier to work with. And then right here, this is kind of like prototypes question mark, dojo.byId. So really, really pretty basic. So okay, so you've seen kind of some of the facilities that Dojo gives you and how Pubtools Search is using that. I want to share with you some tips and tricks that you'll encounter. The most important thing, if you walk away from anything like this, do your intensive operations on workers. The first iteration of this, I did the indexing, I did the search, not on a worker, and I was sad because I was like, oh, this is slow. And then I refactored it into a worker, and it was very, very fast. And the browser, like before, it would like take 8 seconds, and the browser would kind of lock, you know. So if you're doing lots of database, if you're doing lots of networking, because you can actually make an XHR call on a worker, and obviously searching the full text search using that SQL. Remember I mentioned that making a database name. Remember we saw db.open and I passed in a name? This is a common place that you can make mistakes that you don't catch. So one of the things I recommend is use window.location, because there might be multiple, if you just say, my app, and that's used on multiple different pages, you're going to have collisions if you don't want those. So one trick is grab window.location, then remove invalid characters. You can't have a colon, you can't have slashes in a database name. Turn those into underscores. At the very beginning, add an app-specific label. So for this one, I add st underscore and then the URL. And I don't mention it here, but if you're creating a Gears app that multiple users might be signing into the same OS account, you should add the username to this as well. So it could be st underscore Brad underscore whatever. If you don't have a concept of users, don't do that. But that can help to avoid errors that I've seen others have down the road. And then your length is 64. So you put these at the beginning, trim that to length 64. So if you want a function like this, you can look at the code of this. This is under BSD. You can grab that function. I mentioned when you make a worker, you have to pass things in as a string. Well, when you start using workers, that gets really complex. So you want to stringify your workers, and here we're doing that. So this is actually a snippet from Pubtools Search where you're actually seeing entries from the Dojo declare, and you see the index function, and you see a worker script variable. Well, the two things we're doing here, first off, we stringify the method getTitle, which you see down there, and then we actually assign it to that variable so that here's something that's important to know. Remember earlier I had function next prime and I stringified it? That will actually turn into the word function next prime. But if I have methods that are part of an object literal list like this, it's just going to say function with no name. So that's why I'm giving it a name again in that string. And then right there, I'm actually the .on message. When that worker is asked to do something, that's the function that's going to get called, index worker. So, and then the code below that obviously instantiates the worker. Something else that can really simplify, yes, you can only pass strings around. And that's not as much of a limitation as you think. Does everyone here know what JSON is? So what you can do is you can kind of come up with your own lightweight sort of message passing system, but it can be really useful to just use JSON. So right here, again, this is source code from the project. We make our worker. There we're passing in that worker script you just saw earlier. Then we make a message object. We give it a URL, a MIME type, a doc, and a DB name. This is the values we're going to pass into the worker. Because remember, a worker needs to be given all of its info. And then we're using a Dojo function here to turn that into a string. pu.toJSON. Now notice here I didn't use the string function. I could use that around a function to stringify. When you're dealing with a data type, it's better to use a JSON library because there's some like escaping issues and things like that. And then we send that message to the worker. And on the other side, it's going to turn that back into a JavaScript object using eval. Now, I don't talk about cross-domain workers in this talk, but if you know what they are, it's important, don't use JSON. Because then if you do, you're getting rid of all the benefits that cross-domain workers. Cross-domain workers let two sites talk to each other. You want that just to be strings. You don't want it to be arbitrary code. So if you know what those are, bookmark that. When you're doing your design, don't use JSON for cross-domain workers, or you'll run into security issues. This is another tip and trick. So a lot of times when folks write JavaScript that they'd like to have be reusable, and that's a fairly large size, they'll, so first level is they just throw lots of functions into the library, and it pollutes the global namespace, right? So if they drop it into a page, there's going to be, this is going to be everywhere. The second level is they'll at least namespace something. So they'll make everything be myapp dot, right? Make a global object called myapp, and they'll put everything on myapp. The problem with that is all of your internal code needs to say myapp dot, and it can actually bloat your code and actually kind of make it hard to read. You can do a trick. Decide what's your external interface. What's the thing you want to expose? And then everything that's an implementation detail, put it inside of a closure, which will hide those things. So for this, I've talked about the search tools class. That's the obvious public entry point. Gives you like two methods. If someone wants to attach their own UI, right? Search and handle error. So you see that here. Variable search tools equals function. Inside, I do all my dojo.declares, search tools, UI, search, manifest documents. Those are going to be hidden. Anything outside of this JavaScript file is not going to see those classes. And then finally, you see search tools equals new search tools, and we return the search tools object, which will now be in the public scope. And then finally, you see the little parentheses, which executes this function. So you can think of this, like in C, you put if-def headers at the top to make sure something's not included multiple times. This is a nice idiom to kind of not expose so many things. And now I don't have to constantly say, the second iteration of this had like, st.searchtools, st.ui to globally namespace. So it's much more readable. Do you have a question?
Yeah, so one problem with the namespace trick is that within Firebug, all those functions end up being just anonymous. So you can't tell what's going on in your code stack. Does this have the same problem?
Yeah, so sometimes when you start doing these kind of tricks, closure tricks, it can make it hard to get function names through Firebug. You can still set breakpoints and things like that if you're having an issue. So yeah, there's a trade-off. So yes, I didn't repeat the question. The question is, sometimes in Firebug, when you use closures, you don't get to see the function. So finally, I want to run through a little bit of the code. I want to show you the schema, and I'll actually show you the create database tables method. I'll just put the whole thing up here. Really straightforward. Get the database, open it. There's that DB name, using a method, using the tips and tricks I told you to kind of come up with a good name. There we are creating our table. Really simple schema. We have two tables. We have a client metadata table that records the version of the manifest file we've dealt with. And then it also records a schema version. This is important. If you want a system that lives long, you're going to have to eventually upgrade your schema. Let's say a new release comes out. So it's nice to have a metadata table that records your schema version. Or you could even capture the create table information in there. But it's useful to actually have a version. And then you could make, let's say you bump that, you could have some code that sees, oh, I've got an old version, here's my upgrade code. We're not doing that here because there's not a new version, but it's a good thing to future-proof yourself. And then finally, we have a finished indexing column. So when I start indexing, what if the user leaves the page? What if the browser crashes? What if something else happens and we don't finish indexing? So we actually set that to false. We set it to 0. So if we get in the middle of indexing and don't finish, the next time we load the page, we not only look at the version, but we say, did we finish indexing last time? That's important. Whenever you're doing operations like this, you need to record. So at the very end, then I set finished indexing to true. And I'm actually not using transactions for this. I probably should update my code to use transactions. But you can actually put everything in the index into a transaction for that thing, and you could actually catch an error and do a rollback if you wanted to do that. So there is transaction support in SQLite. But think about this. I can't surround the whole thing with a transaction because each of those are asynchronous. So that's one of the reasons why I need this flag. And finally, you see here we are creating that full text search table. So there's the syntax, making a virtual table called client search. And then we're saying 4 columns, URL, title, MIME type, and then our content. Something that's important is there's a create table if not exists. So I can run that over and over every time I start. But that doesn't exist for a virtual table. So to simplify my code, I run create virtual table surrounded in a try-catch block, which will throw an exception if it already exists, and I ignore that. Otherwise, the code actually bloats a bit, where I have to run a select, see if it exists, and so on. Let's look at the index worker. Here is that function, index worker. And remember, we stringify this, so it gets run on the worker. Remember we JSONified our input? There we are evaling it back into a real JavaScript object. Message is an object that Gears gives us, and message.text actually has the text. Just to know, coming in a future Gears version, Gears will do this for you. You'll have message.body, which will JSONify and undo that for you. But that's not there yet. There we are extracting the title. Then we create our database. And there we are. Inserting into the full text search is really straightforward. We just insert in the client search. There's all of our values. And that, under the covers, does the full text search indexing. And then we close. And finally, when we're done, we send a message back to the guy that made us. Hey, look, we indexed this. Oh, and then we're saying, this comes from us. That's kind of the syntax used. So this is the last bit of code we'll look at. This is the searcher class. So look up a piece here. So search function. Here's our worker script. We don't stringify this one because we do a little differently. It didn't make sense. I didn't want to use eval. So I'm sorry. So I could rewrite this code to use the same trick, but I did to JSON, the query and the DB name. So I'm using, this is when you don't use JSON. You see I'm passing in a string and splitting on the colons to get my parameters. That's kind of the other style. And there I am doing the full text search, select all from client search, where it matches some query. So right here, now I'm looping through the result set of what matched, and I'm building up an entry. Entry.title, I get the title column, get the URL, and so on. Then I generate a snippet by calling getSnippet. And then I build up an entry string with the values. Now I could have used, again, now you get to see what's nice when you use JSON. This is kind of the other style when you're not. I'm having to manually build up a string. And I'm also having to manually escape. Oh, I remember why I did this. When you're running on a worker, you don't have access to library code as easily. And I actually originally tried to stringify the Dojo to JSON from JSON functions, but they referenced too many other things to do that easily. And it was hard to untangle that. So I just went ahead and did this and grabbed the escape string method. So you'll run into that too. On a worker, you can't call library code as easily because a worker lives in its own context. So if you've got prototype or jQuery, that becomes a challenge. And then finally, once we've looped over, we're passing back the string with the results. So the status, I really wanted to have Pubtools Search done by now. I wasn't able to get through the open source review process. I got some more QA. So unfortunately, Pubtools Search is still in development. It's not released yet, but it will be soon. And it's some code that you can really use as a template for your own projects. And let's take some questions. Thank you. Yes.
Just a sort of generic gears question here.
Just can you speak up a little bit?
Oh yeah, absolutely.
Thank
Just sort of a generic gears question. I heard you and I heard a couple other people say that the worker threads actually give you a speed up. And I'm wondering, is that just an apparent speed up, or do you actually have your own sort of JavaScript execution framework that actually makes the JavaScript faster?
So the question is, he's heard that worker pools can give a speed up, and is that a real speed up? What is that related to? So that actually is a real speed up. When the JavaScript is running inside of the browser thread, it just doesn't handle that very well, and it locks things up, and it can take longer. So it does give you a real, it's not just a perceived performance. When it runs on the worker, there's a real performance improvement because it's not blocking, waiting to see if the UI is happening. With that said, right now, the JavaScript interpreter that is instantiated on the worker is actually the same one in the underlying browser for right now. So on IE, it's the IE JavaScript engine. That's true right now. The other thing to know is that workers use the OS's threads abilities. And if that OS can spawn a thread on a different core, then a worker will spawn onto a different core, and you would get a performance improvement because something is running multi-core. So that's it's a good question.
Hi. I'm wondering if the full-text search can give you regular expression search or partial string matching?
So the question is, can I do partial search or regular expressions? I know you can do partial search. I don't know if you can do regular expressions, actually.
Okay.
I'm not sure. Okay, so you can do prefixes, but otherwise it's the whole word.
My question was pretty much related to what he asked. Like, does the worker spawn a new process, or like, you just mentioned that it operates in its own context. So is it a new process, or how does it actually perform this parallel operation?
So the question is, does the worker spawn a new process? How is it actually working?
How does it achieve this parallel processing so that the speed is increased in execution? Like, without workers, the browser was used to block the on JavaScript execution, but with workers, that's not the case.
Right, so the first thing is I actually haven't gotten to see that lower level code in terms of how the worker's doing things. It's my understanding that it's generally starting a thread, and then it's most browsers have facilities to do inter-thread communication to safely message back and forth. And so the JavaScript interpreter can actually be started on another thread, and the results can be passed back in a safe way. But more than that, I don't know the particulars of that code.
Do you have some demo about Gears application?
I'm sorry, can you repeat your question?
Demo?
Is there what?
Do you have demo about Gears application?
Okay, did you see the demo at the beginning?
Yeah, but it's just too short.
Was that?
Too short, that one.
To show others?
Yeah, there are others.
Well, there's a lot of Gears applications, and so unfortunately I wasn't able to release this quite yet, so this will be a demo that you can access when it is. Other demos include Zoho, uses Gears, MySpace, launched with Gears recently, Google Docs, Remember the Milk, Bucksfur. So there's lots of consumer publicly available apps that are good showcases.
Okay.
What's that? So the question is, the comment is a copy of Search Pub on Gears. Is that a question? Okay, so there's an older thing called Pubtools, which is slightly different. Again, that's not part of Gears. It's important to say that. This helps you take static content offline, and it's not using Dojo. Cool. Any other questions? Yeah. Do you mind coming to the microphone? Thanks.
There's a site on Google Code called Gears-Pubtools.
Yes.
That where we'll find
so
the code?
The question is Gears-Pubtools. Right. The code will be there when it's ready. what you're seeing there is an older iteration that helps with static content, and there's documentation for that there. Pubtools Search is another sort of example showcase of this kind of stuff, but focused on search, and it will appear there. And so, all right, folks, we got to end. We're out of time. Thank you very much.